Hi, welcome back to day 3 of Volumes of Revolution. Now, in day 1, we talked about just how can we revolve one function around an axis. In day 2, you might recall we revolved um, the area between two functions around like an x-axis or y-axis. In day 3 today, we are going to revolve a region, but this time we're going to pick a new axis, such as like y equals -5, where it's no longer the x or y axis. So this becomes slightly more challenging to do. So let's go ahead and take a look at this example. We want to find the volume of a solid of revolution generated by revolving the region about of the line y equals 2x, y equals x squared about the line y equals -5. So the first thing I'm going to do is I'm going to focus on this axis of revolution right here. There it is right there. There's our axis. And notice that y equals -5. So on the y-axis, we're going to go down here to -5, not draw on the scale. So there's y equals -5. There it is. Now, if we notice, this is going to be parallel to the x-axis. So if I were to draw a rectangle from the axis of revolution, like we did in day 1 and day 2, to the function, we have to draw a vertical rectangle. So that's nice. So this is telling us that we have a vertical rectangle of mathematics, and therefore we have to be in terms of x. Remember, we always have to be careful. Are we in terms of x? Are we in terms of y? What's our axis of revolution? We have to be very careful with it. So now notice we are looking at the area between these two graphs right here. And you can see the Shady song, I'm Slim Shady, yes, I'm the Slim Shady. Now, because there is a big gap, an open gap between the shaded region and the axis of revolution, this is telling us we are going to be using our washer method. Now, all the washer method is just basically two disks. So we are going to have an outside disk, and we are going to have an inside disk. So let's go and draw it. To get the outside disk from the axis of revolution, we are going to measure straight to the very tip top. There we go. There it is. There's our famous rectangle of mathematics. When we revolve this, this will give us a disk, like so. We can find the radius of that disk pretty darn easily. The radius, remember, is just going to be the top function minus the bottom. But be careful, the top is going to be our line, this 2x, so we're going to do that. Top minus the bottom. But this time, the bottom, remember we talked about the bottom in the last video, is always the axis of revolution. So the bottom is down here, and it is our axis of revolution at -5. So this is going to become 2x minus a -5. Now, the height of our rectangle is still going to be dx. Now, I'm going to get rid of this because I'm going to need to draw in there real quick. Now, so my radius, therefore, will be 2x plus 5. And the height, just dx. To get the inside disk, we measure again from the axis of revolution to the lower function, the bottom function, or the one on the very bottom, the closest to the axis of revolution. This is the one that's causing us our gap. So same thing, if I just draw my disk out, it does have a radius. And again, the radius, again, top minus the bottom. If I go to the inside one, there's my top. Remember, this is my inside part. There's my in. The top is on that parabola, x squared. Oop, not 2x squared, just x squared. The bottom is on the axis of revolution again. Remember, the bottom is always going to be our axis of revolution, which in this case again is -5. And we get this x squared plus 5. We do have a height, which is again dx. And we're just going to, that's all we need. So to get the volume from the other day, we said this, the volume is pi r squared h. But here we're looking for the volume of the outside function minus the volume of the inside function. So we just got to do it twice. The outside function, it's just going to be pi, its radius is 2x plus 5 squared. The height is always dx minus the inside, pi x squared plus 5 squared dx. And I can shortcut this. You might remember in the other video, we said, well, they both have a pi and dx and the same one. So we can kind of factor those out if we wanted to. And I can write this as pi 2x plus 5 squared minus x squared plus 5 squared dx. And let me go back way up here at the very beginning. Okay, this is from yesterday. There we go, right here. And this is what we're saying. Pi dx, and we got the outside radius squared minus our inside radius squared. So we're just using that formula again. So let's see what we got here. So the only thing I can do now, well, I can integrate it. So I have to find their bounds. Where do they meet? And that is just where does the line function 2x equal x squared? And I can bring it over. X squared minus 2x equals 0. And you can get x is 0 and 2. So we just integrate that from 0 to 2. All right, in another video, we are going to check these with the calculator. Just give me a little bit, okay? We're going to check these with the calculator. I don't have my calculator set up right now, but we're going to take a look at that in another video. But let's go ahead and move on to number 5. Now, let's take the same region, but this time we want to revolve it about the line x equals 2. So let's take a look here. So let's say here is x equals 2. Notice this time our axis of revolution is vertical, which means this is parallel to the y-axis. So therefore, this has to be in terms of y. So now we're going to be in terms of y. And the reason for that is simple, okay? Because if I were to measure from here, the axis of revolution, to my function, I have to make a horizontal rectangle. That's why we have to be in terms of y, because we are looking at a horizontal rectangle of mathematics this time. So let's go ahead and draw that rectangle. I'm going to get 2 of them this time because, again, I have this big open space, this big old gap right there. And because we're only looking at the region, again, in between here. So if we were to measure to the outermost function, take a look at it. There it is. There's the outside function. This is the outside part. There's my outside rectangle right there. Notice this time when we revolve it, it's going to be a horizontal one. So if I look at the outside bit, it's going to be horizontal. To get the radius from the center, we're going to go right minus left this time. So be very careful. This is really tricky. For a rectangle, what's on the right? That's right, it's the 2. Normally it's the function, but this time it's the 2. The 2 is on the right. Gotta be really careful. Minus the left is our line. It's the one furthest out. When we say the outside, we're the furthest out from the axis of revolution, and that's our line, 2x. So the radius is just going to be 2 minus 2x. The height, well, that's just dy this time. Oh no, you might notice I made a huge mistake and I'm too lazy to go fix this. So let's fix it. Oh no, we made a big mistake here. Anybody know what it is? Real quickly. That's right, I forgot to change my variables. And it's okay, I made a mistake, I'm going to go back and fix it. We make mistakes. If we were to draw our rectangle of mathematics, draw our disk again, we have to be very careful. There we go. When we do the radius as the right minus left, I forgot to change my variables. Remember, we have y equals 2x, so therefore we could say x equals y over 2. We have y equals x squared, so therefore we can say x equals the square root of y. So we'd be very careful. So when I did the right minus left, the right is still the 2, which is what I want. But it's the left that I messed up on. The left is our line y equals 2x, but it's got to be in terms of y. It needs to be y over 2. I'm going to hear about that in my comment section, I'm pretty sure. The height is just dy this time. Now, let's take a look at the inside disk. So I'm going to go ahead and erase this real quick. Whoops, not you. To get the inside disk, we go to here. There's my inside rectangle. It's the part that measures the gap. And again, it's going to be horizontal. So the radius is still going to be right minus left. On the right, let's take a look here. On the right, I still have that line x equals 2. So my right is still 2. My left, it's going to be that parabola right here, which is y equals x squared. But in terms of y, we write it as the square root of y. So we solved that earlier. So that's the square root of y. The height is still dy. So if I were to write this out, volume is volume of the outside minus volume of the inside. And I can write this, the outside volume is pi 2 minus y over 2 squared dy, because remember volume is pi r squared h minus pi, the radius of the inside, 2 minus root y squared, remember volume, dy, pi r squared dy h. Same thing. Now, remember, I do have a common variable. They both have a pi, and they both have this dy right there. So I can factor those out if I wanted to. And I'm going to go and do that. Makes it easier to type in. This now becomes 2 minus y over 2 squared minus 2 minus root y squared dy. And all I have to do now is find out where they meet. But be careful, we're in terms of y this time. So to get where they meet, I take y over 2 and set that equal to the square root of y. Solving it, if I square both sides, I just get y squared over 4 equals y, or y squared minus 4y equals 0. So therefore y is 0 and 4. Oh, that's a pretty 0 and 4. Of course, another way to do it is that, look, I know x is 2, y would be 4 in both those cases. I guess I probably could have done it that way, but you know what? I nerded it up a little bit. And there's our volume. All right. When again, in another video, we'll take a look at how these on the calculator. I hope you enjoyed this video. Go to video number 2. We'll take a look at a few more examples. I'll see you then.